Howdy there, folks. Today we're going to walk you through balancing chemical reactions level 2. And for this, you're definitely going to want your periodic table. So make sure you go back to our resource library under your classwork stream, and you can find the periodic table that we use in class. The most important part today is going to be the back page, common polyatomic ions. Let's take a look. On this homework, it's the same steps as before, but notice that these reactions are a lot more complicated. It's a double replacement reaction, meaning that we have big compounds, um, bigger than we saw in our last balancing reactions. The thing that makes this hard is because now we have one, two, three, four, five, six different elements to keep track of. Well, I guess just five because there's oxygen here and here. But if you remember from the last level 1 balancing, every time we did a combustion reaction, oxygens were in 2 places. So now we have oxygens all over the place. Ugh, how to make this easier? Well, notice how these ones are in parentheses. These parentheses are going to tell you that you're going to treat them as families. Treat them as families. So we have our uh, first element. If it's just an element that's not a family, you can write it just as that. So I've got PB there, and I've got NO3. Remember, make that 3 a little one. And you can go back to double check, is this a family? NO3. Yep, there's my family right there, NO3. So the little number that's part of the family name is how you count. The little number that's outside of the parentheses is how you're going to uh, multiply through to count those, right? It's not part of its name. It doesn't multiply 2 times 3. When we count it, it's just going to be 2. All right, over here we have K by itself. Remember that 2 is how we count it. It's not part of its name. But the other one that's there, CrO4, remember that 4 is the little one. You can find that doing format, text, subscript makes it little. Okay? All right. So let's count. On the left-hand side, we have 1 PB. The NO3, there's a 2 right there. So that 2 multiplies to this whole NO3. Do not multiply it by the 3 because it's part of its name. So counting the NO3s, I have 2 of them, 2 Ks, and just 1 CrO4. Remember that little 4 is part of its name, so don't count it. On the right-hand side, there's 1 PB. CrO4, there's just one of those, 1 K, and NO3, no number outside of that, so there's just one of those. So you can see that instead of counting like 2 times 3 is 6 oxygens plus 4, instead of having numbers like 10, ones and twos, much, much nicer. So let's take a look. The PBs already match. The NO3s, 2 on the left, 1 on the right. So I'm going to put a 2 right there to make sure that I'm getting 2 NO3s, right? I was trying to do it for the NO3, but remember it also does it for the K. So on the right-hand side totals, I'm going to change my total to 2 Ks and 2 NO3s. 1 PB, 1 PB, 2 and 2, 2 and 2, 1 and 1. That's the only thing I had to do to balance it. Great. So that means I can put ones in for the rest of these. I'm all done with number 1. Let's check out number 2. And number 2, notice I've got the family thing going on again. The H3PO4, gosh, that looks like a family. Hey, there it is on the right. PO4 is in parentheses over there, but just in case you're worried, you can go back and check your periodic table. PO4 is a family. Okay, so if I'm writing down the elements now, I have Mg, I have OH. This one, my PO4 is the family, so H is by itself, and PO4 family. Okay, let's count. On the left-hand side, I have 1 Mg and 2 OHs. Remember, when there's a little 2 outside, it just multiplies by the family. It does not multiply the whole thing. Only when you have the big number in front, like up here, only when you have the big number in front does it multiply all the way through. The little numbers like this just go to the one that it's right next to. Counting the H's, I have 3 H's and 1 PO4. Remember, that 4 is part of its name, so there's just one of those. On the right-hand side, I have Mg's right here. I've got 3 Mg's. Here's the 2 outside the name. Remember, the PO4 is part of its name. The 2 is how we count it. So I've got 2 PO4s. And then, wait a second. These are H's, but I don't have O's by themselves. This is the second trick for this level 2. The first trick was to count as families. The second trick is to recognize that this H2O is really an H and an OH. So remember, H2O, that 2 means that there are 2 H's and 1 O. So what if I rewrite this as HOH? 1 H, 2 H's, and 1 O. Do you see the family now? Yep. It's hiding. Don't let your water play hide and seek. So what I'm going to do is I'm actually going to change this from H2O and put it in as HOH because I want to be able to see that family when I'm counting. Now it's way easier to say, oh yeah, I have 1 OH and 1 H. All right, let's start balancing. 3 mg's on this side. I need 3 on this side, so I'm going to put a big 3 in front of there. Remember that 3 distributes all the way through. 3 mg's, which we were trying to change. So I'm going to change my mg's to 3. But remember, it also changes to the OH. It also goes through. So 3 times 2 gives me 6 OHs. Okay. Change my mg's. They match. OHs, not so much. I need 6 on this side because there's just 1. 1 times 6 gives me 6. But remember, it multiplies through 6 H's and 6 OHs. It goes to both. So I have 6 OHs and 6 H's now. All right, my mg's match, my OHs match. These do not. Okay, let's figure it out. I have 6 H's on this side. I need 6 H's on this side. But remember, there's already a 3 there. So 3 times something gives me 6. 3 times 2 gives me 6. But that 2 multiplies through. 2 times 3 gives me 6 H's. But don't forget to also do it for the PO4. 2 times, there's just 1 PO4. Remember that 4 is part of its name. So 2 times 1 is 2. Check it out. 3 and 3 mg's, 6 and 6 OHs, 6 and 6 H's, 2 and 2 PO4s. I can put a 1 here to say that I didn't have to change that 1 at all. All right, ready for the last trick? The first trick was write down the family instead of individual elements. The second trick is that sometimes OHs can be hiding in an H2O, so make sure you take those out of hiding, right? Show it in full daylight. Peekaboo! And now finally, for our balancing trick number 3. This is a combustion reaction, right? We've got O2 and CO2 and H2O. So we're going to do the same thing as before, C's and H's and O's, and count them. 4 C's, 10 H's, 2 O's, right? 4, 10, 2. And on the right-hand side, 1 C, 2 H's. Remember, combustion are harder because we have oxygens here and here. So 2 plus 1 gives me 3 oxygens. All right, let's fix the carbons first. I need 4 on this side, so I'm going to put a 4 right there. Okay, so it changes my carbons. 4 times 1 gives me 4. And it changes my oxygens. 4 times 2 is 8. Plus 1 is 9 oxygens now. All right, 9 oxygens. Remember, I'm adding 4 plus 1. My carbons match, so now I'm going to change my hydrogens. I have 10. I need 10. So to make that 10, 2 times 5 gives me 10. But remember, I need to multiply this through. 5 times 2, I did it, so I changed the H's. But it also changes the O's. 5 times 1 gives me 5, plus 4 times 2 is 8. So my oxygens are 8 plus 5. 8, 9, 10, 11, 12, 13 oxygens. Okay, so this is where things get a little bit wacky, right? This is the third trick. Carbons, 4 and 4. H's, 10 and 10. Oxygens, 13 and 2. How do I get 13 over here? Well, this means that we can use some exciting fraction math. So remember that if you want to get rid of a fraction, Well, if you want to get rid of our 13, what if we took this 13, right? 13 times 2 would give us an even number. Aha! We could use a fraction, 13 divided by 2, and then multiply it by 2, right? So 13 divided by 2 times 2, those 2's would cancel out. So if we balance it with this improper fraction, 13 over 2, we actually get 13 oxygens to match that. But we want to balance with a 13 over 2. So the easiest thing to do is just multiply everything by 2. So I'm going to take this and multiply everything by 2. 2 times this whole equation. 2 times the whole equation. So 2 times 1 is 2. 2 times, we did this with, if we balance it with 13 over 2, 2 times 13 over 2, right, really just becomes 13 because the 2's cancel out. 2 times 4, this coefficient becomes 8. And 2 times 5, this coefficient becomes 10. This is a lot of wackiness. What I'm going to do is erase this for a moment. So to state how to solve this difficult combustion reaction more plainly, if you end up with 13, right, or some other odd number, the best thing to do is to multiply everything by 2 to make those odd numbers go away. So right now there's an invisible 1 there. 1 times 2 is 2. It changes my carbons to 8, and it changes my hydrogens to 20. I'm going to wait to balance that one. I need to change these ones too to make them balance. So if I actually want 8, and I take 4 times 2 is 8. It changes my carbons to 8. I'm going to wait to count the oxygens in a second. I want to make this one equal 20, not 10. So I need to change this coefficient to 10. So now 8 times 2 is 8 carbons. 10 times 2 is 20 hydrogens. And now let's count the oxygens together. 8 times 2 is 16, plus 10 times 1 is 10. So my grand total oxygens that I have are not 13 now, but 26, twice that. I balance 26 with 2? Yes. All I need to do is put a 13 in front. Now I can say 13 times 2 is 26, and it balances. So this is your third and final trick. If the oxygens come out with an odd number, multiply all the coefficients by 2, and it'll work out. All of these ones should be even numbers, and your oxygen should be an odd number. Hope this helps. Good luck, everybody. Good luck, everybody, and email me if you have questions.